Good afternoon. I'm Christina So, Dean of the Nanyang Business School, and it's my pleasure to extend a very warm welcome to all who are joining us for this inaugural NBS Interdisciplinary Distinguished Speaker Series. This new series is a platform for top scientists at NTU and other universities to share their expertise on important areas that also have business implications. As a premier business school within a leading technological university, the Nanyang Business School is well positioned to address the major challenges of the day, many of which relate to disruptions arising from environmental, technological, and social change. We do this through a multidisciplinary team of faculty members who collaborate with colleagues in other fields and with industry partners, leveraging each other's strengths and sharing resources to both generate impactful innovations and to develop our students. We offer this interdisciplinary exposure to our students through our PhD, master's, and undergraduate programs. And we're very proud of our track record of outstanding alumni who exemplify our goals of sustainable innovation, impactful leadership, and cultural adaptability. This speaker series aims to further encourage our community of students, faculty, alumni, and partners to be informed about cutting-edge scientific discovery and cross-disciplinary collaboration. Some of the topics we have lined up for the months ahead include infectious diseases, machine learning, robotics, and AI. Today, we're very pleased to have Professor Benjamin Horton, Director of the Earth Observatory of Singapore, speak to us. I've known Ben for a few years now, and he is a distinguished earth scientist and a soccer player. So it is appropriate for me to say that we are delighted that he is kicking off the series, and he will be talking to us about his research on the social and business impacts of sea level rise. I will now hand the time over to Professor Simba Chung, Associate Dean Research, who will be moderating today's session together with Associate Professor Yogesh Khatri. Thank you again for joining us, and I trust that you will have an engaging and insightful session.
Thank you, Chris, for the great opening speech and the great support for this cross-disciplinary research initiative. And very good afternoon to everyone, and thank you for joining us in this webinar. It's an inaugural session for this NBS Distinguished Speaker Series. Of course, the aim, as mentioned by Chris, our dean, the aim is to promote collaborative cross-disciplinary discussions that may lead to new research and educational opportunities. So I'm Sin Chang from Nanyang Business School. I prefer to be called Simba, which is my nickname. I'm a professor of finance at NBS and associate dean for research at the moment. I'm currently also doing research about corporate social responsibilities, green finance, and business implication of climate risk, for example. So I'm very glad to know that this webinar has attracted attention from more than 250 people in almost 30 countries. It's quite amazing. So at the start, I would like to conduct a very brief poll with just 2 questions. So the purpose is actually to gauge the general perception about sea level rise among our audience. So you have about 30 seconds to answer the questions, and then we will show the result of the poll very shortly. So and in the meantime, I also encourage you to ask questions during, using the Q&A function. Just type your questions in the chat box. And then our speaker and our moderators will try our best to address your questions. I will be one of the moderators of the session today. Another moderator is my colleague, Professor Yogesh Khatri. Is also academic director for the Master of Science in Asset and Wealth Management. So before Yogesh actually returned to full-time academia, he actually spent about 20 years in public and private sectors. He worked for, he actually held important positions at IMF, GIC, and Nomura Securities in Singapore. And it's now my great pleasure to introduce our speaker today, Professor Benjamin Harton, a professor at the Asian School of Environment, and the director of Earth Observatory of Singapore, at NTU. He's a world-renowned geoscientist, and he's a very established leader of multidisciplinary research on climate science, coastal hazard, and paleoecology. So one of his research specialties actually is about understanding the environmental changes. In particular, he's one of the best scientists you can find today who can help us to understand the mechanism that drive the change in sea level rise and in the past, and how this will shape our future. Okay, so again, apart from all the titles and achievement you can see in this slide, as mentioned by Chris, I can share with you that he's also a great footballer, because I play with him very regularly, of course, before COVID. So I have seen his strong leadership in both academia and in the football field. So without further ado, let's have Benjamin Harton speak about sea level rise, a crisis for coastal communities. Over to you, Ben.
Thank you, Simba. Thank you, Christina, for the introduction. I'm now going to share my screen. I think you need to stop yours. So, can everyone see my screen now?
Yes.
Yep. Okay. All right. Well, good afternoon, everyone. Thank you for spending time on your Friday to listen to a seminar regarding two parts. I'm going to wear two hats. So in the first 10 or so minutes, I'm going to talk a little bit about the Earth Observatory of Singapore, for which I'm a director of. I became a director of the Earth Observatory in the summer, but before that, I was a principal investigator for many years. And then following that, I'm going to talk about my area of expertise, which is sea level rise. I've been studying sea level rise for all of my career, so some 25 or so years. And I was a lead author on the 5th assessment from the Intergovernmental Panel of Climate Change. And we are currently writing the 6th assessment, for which I am a review editor. And I'm the only physical scientist from Singapore on that report. So to begin with, the Earth Observatory of Singapore. Well, the Earth Observatory of Singapore is a research centre of excellence. It's governmentally funded. There are 5 of these centres in Singapore, and 2 of them are housed at the Earth Observatory. It has a story that it began not long after the Indian Ocean tsunami. So the Indian Ocean tsunami occurred at a rupture of the Sunda megathrust. It was a rupture of a magnitude earthquake of approximately 9.2, the second largest since instrumental records began. It took the scientific community by surprise and unleashed a tsunami that devastated the coastlines of South and Southeast Asia. As a result, in 2008, the Earth Observatory of Singapore was founded, and it has a mission statement, and the mission statement is as relevant now in 2020 as it was when the Earth Observatory was founded, and that is to conduct fundamental research on the sciences of earthquakes, volcanic eruptions and tsunamis, and climate change. Our subject, or our spatial area, is Southeast Asia, and we have this objective of helping societies become safer and more sustainable. We have an EOS logo. You can see it when you come into the offices here at NTU. You can see it on our slides. The EOS logo has 4 colours. They represent the 4 research themes of the Earth Observatory. They're supposed to illustrate their dynamic concept, which is all around the subject of Earth system science. So our 4 research themes. When the Earth Observatory was formed, it started to specialise initially in the tectonics, understanding the earthquake risks, and understanding volcanoes. It subsequently developed to look at these hazards and risks and their impacts on society. But science changes, public interest changes, and governmental interest changes. And in the last 11 or so years, we've had an increasing emphasis in climate change, in particular following our president's address at the National Day Rally in 2019, where he dedicated a significant amount of time talking about the sea level risk to Singapore. The Earth Observatory of Singapore is a large research unit. We have approximately 130 researchers, staff, and PhD students. And this doesn't include the undergraduate students that are associated with the Asian School of the Environment. Our staff come from everywhere, all corners of the Earth, mainly from Southeast Asia, but we have scientists working in the Earth Observatory from Australia, from Northern Europe, from North America. And it is this world base of talent which enables us to have a global impact in geohazards and climate change. Now, you may ask yourself, why would there be an Earth Observatory of Singapore based at NTU in Singapore? Well, that's quite simply because Singapore is in the center of what we call the Southeast Asian Ring of Fire. It's in the greatest concentration of geohazards or climate threats on our planet. And coupled with that, we have the highest population densities. So hazards can quite quickly turn into disasters. On tectonics, we have significant seismic hazards in the Himalayan Tibetan region, moving down through the Sunda megathrust of Sumatra, Java, into Papua New Guinea, the Philippines, and elsewhere in the South China Sea. Many of these seismic hazards have the potential to generate devastating tsunamis. And at the Earth Observatory, we have examined the tsunami threats for many areas of the coastlines of the South China Sea. Tropical cyclones. With climate change, the intensity, the size, and the frequency of these tropical cyclones will change. And they cause devastating effects, as we've recently seen in the Philippines. Volcanoes. Surrounding Singapore are a colossal 900 active volcanoes. Each one of those volcanoes have the potential to devastate local and regional communities. And regarding sea level rise, well, it's anticipated by the end of this century, 1 billion people will be inundated by rising sea levels if we don't do anything to mitigate the underlying cause of greenhouse gases. And 70% of that population will be in Asia. Regarding the Earth Observatory of Singapore, the unique aspect and the heartbeat of the Earth Observatory is our Centre for Geohazard Observations. Here at the Earth Observatory, we have a variety of scientists that have technical expertise to install instruments, to maintain those instruments, and continuously download the data in real time to better protect Southeast Asia. We have a variety of instruments located in 8 countries around Asia, predominantly in Indonesia, but also in the 7 other counterparts. In total, we have 175 stations, and these stations record how the Earth moves, which enables us to estimate where the areas at risk from earthquakes are. We measure volcanoes, in particular their heat content and their gas content, to indicate when they're going to potentially erupt. And we measure both the atmosphere and the oceans to try and understand climate change. We have connections with Amazon and their cloud to enable us to transfer huge amounts of data so we can respond to disasters in real time, approximately 6 hours. Now, regarding the Earth Observatory of Singapore and its research on climate, we concentrate primarily on sea level right now. The Earth Observatory of Singapore has been successful in bringing in funding through a Tier 3 grant, the largest grants that the governments give out from MOE, and also being an integral member of the National Sea Level Programme. I mean, in the last 6 months or so, we've generated over $15 million worth of research funding on this topic. So this topic includes a variety of aspects. We go to we're starting, the COVID pandemic has restricted our research, obviously, here to Singapore. This is a much larger framework looking at Southeast Asia. Where we go to Pulau Ubin to look at the susceptibility of mangroves to sea level rise. We do a variety of sediment cores. We've got a big sediment coring program going on as Jurong Lake is redeveloped. And so what we're trying to understand there is how did sea levels change in the past? And I'm going to show you some results later on. We use corals because corals can tell us about sea level changes in the last century. And we're installing a variety of instruments in and around Singapore to understand changes in sea level in the present day and in the next decade or so. We also have programs within the Earth Observatory looking at precipitation changes. So in the Indo-Pacific is one of the warmest waters in the world, and the evapotranspiration of the Indo-Pacific changes rainfall patterns. So here at the Earth Observatory of Singapore, Professor Jianfeng Wang uses geological archives again to try and look at past changes in rainfall. So we use speleotherms, which are stalactites or stalagmites. We have a laboratory here in the Earth Observatory, one of the best in the world, that uses uranium series dating to identify the time period in these speleotherms, and then uses a variety of other isotopes to record how there have been changes in rainfall in the Indo-Pacific from the present day stretching back over 400,000 years. Another archive that we use, I mentioned it previously, but we also use corals to understand how our ocean currents are changing. Here in the Indo-Pacific, there is a lack of instrumental measurement, so we have to use our geological recorders to provide that data. So, working out in Taiwan, we're trying to understand parts of the ocean circulation. It's called the ocean conveyor. It's the ability of the Earth to transfer warm waters at the equators to the high latitudes. It basically, these ocean currents, if they're not functioning at their full potential, it can cause dramatic changes on our climate. So we use this information from the corals because they have growth rings just like tree rings, and you can stretch back our understanding of ocean temperatures, ocean salinity, and circulation of ocean currents over 500 years. Regarding tropical cyclones, devastating events. And with climate change, we're warming up our ocean waters. If you warm up ocean waters, you give the tropical cyclones more energy, and therefore they will become more intense. So a tropical cyclone is more likely to be a category 4 or 5 than a category 1 or 2. They're going to be larger, so they're going to influence a regional rather than a local region. They're also going to be slower moving, and that means they can commonly stall over a region and deposit huge amounts of rainfall, which we've seen in the Philippines over the last couple of weeks, causing devastating landslides. One of the events that we covered in much detail was Typhoon Haiyan. Typhoon Haiyan, when it made landfall in the Philippines in 2013, was and still is the highest recorded wind speeds ever from a tropical cyclone at over 200 kilometers per hour. We, as the Earth Observatory of Singapore, we map these disasters, we give information, as I said, within 6 hours of the extent of those disasters to aid agencies. Then several months later, we go in and we understand the sediments, flood heights, and survivor accounts, so we can develop models to make areas more resilient in the future. So that's an introduction to the Earth Observatory of Singapore. I'm sure many people that are listening in today didn't know much about what we do. You now know that here at NTU, we have a centre of excellence that basically is trying to keep Singaporeans and Southeast Asians safer and more sustainable from climate change and other geohazards. Now what I'd like to talk to you about is this initiative that we have within the Earth Observatory on sea level change. It's called the Southeast Asian Sea Level Programme. It's been funded, as I said previously, by, it only began in October by a Tier 3 grant, and we have some National Sea Level Programme awards which begin in January of next year. The information I'm going to show you today is based around a review paper that myself and Bob Cott left. He was one of my former colleagues from my previous university at Rutgers University, and our research groups. And we publish this in annual reviews. And if any of the listeners would like to see this or the other subsequent papers that I'm going to show, I can freely make them available. So sea level, despite its name, is far from a flat, planar surface. It varies from space to space, and that's because there's a variety of processes that influence sea level on a local, regional, and a global basis. And what I'm going to do right now is I'm going to show you some of these processes so we get a bit of an understanding of what controls sea level. Then I'm going to show you some examples of how sea level has changed in the past. We're going to look briefly at how sea levels have changed in the present, and then we'll think about how sea levels will change into the future. So at the local scale, we need to understand processes such as groundwater withdrawal. So in many regions, our coastal aquifers are being depleted for industrial, agricultural, and commercial use. You deplete the aquifers and the land subsides, amplifying sea level rise. Here in Southeast Asia, as I illustrated previously, it's got many, many tectonic faults. And this causes the land to uplift, diminishing sea level rise, or to subside, amplifying sea level rise, both during an earthquake, but also the solid earth responds during an earthquake. So we need to understand those processes. I'm going to introduce you to two other concepts. Glacio isostatic adjustment. This is the response of the land surface to existing, but importantly extinct ice sheets, and it has a significant influence on sea level in our northern latitudes. I'm also going to illustrate you a process known as static equilibrium, which is the response of the Earth to gravitational changes when you lose the mass at the poles. Globally, the two dominant processes are changes in ocean volume and changes in the mass on our planet. So ocean volume has dominated sea level rise in the 20th century. It is the increase in atmospheric temperatures being transferred into the surface waters of our planet. The water molecules occupy a greater space, you increase the volume, and sea level rises. And it has contributed somewhere between 30 and 50% in the 20th century. But as we move into the 21st century, it is our ice sheets that dominate. When you increase atmosphere and ocean temperatures, you melt our land-based ice from glaciers, ice caps, and ice sheets, and it's transferred into the ocean basin. Since 1994, we have lost 28 trillion tons of ice from our land-based ice on our planet. That is a colossal volume, and it's increasing. It's about 0.8 of a trillion tons in the 90s. It's around 1.2 right now. Now, trillion tons, what does that mean to you? If you've lost 28 trillion tons of ice, if you put that ice on Singapore, cover the whole of the area of Singapore to a thickness of greater than 30,000 meters, That's how much ice we have lost. And but it's only a small fragment of what ice we have on our planet. Greenland. Greenland has enough ice within it that if it was all to melt, it would cause sea levels to rise 7 meters. But it is Antarctica that we are exceedingly worried about. Antarctica has enough ice within it because it is colossal. It's greater than the size of Australia. It's up to 2 to 3 kilometers thick. If Antarctica disintegrates, it has a potential to rise sea level 60 meters. So you only need a small percentage of these ice sheets to melt to have devastating effects around our planet. So they're the global drivers. But if we want to understand what's happening in Singapore, in New York City, in London, in Sydney, we have to understand regional drivers. And I said, I want to illustrate these to you. The first one is Glacio isostatic adjustment. And this is the movement of the land in response to ice sheets that were extensive over the northern hemisphere 20,000 years ago at the last glaciation. So in areas underneath these large northern hemisphere ice sheets, the Earth isn't a brittle solid, it's a deformable plastic, and the Earth deforms and it subsides. When those ice sheets are removed, the land uplifts, rebounds. At areas at the margins of the ice sheets, they were uplifted at the last glacial maximum and are currently subsiding. So some models that we have driven at the Earth Observatory show the current, this process began 20,000 years ago, but it still influences the Earth today, the current changes in land level. So in areas in Canada, Hudson Bay, or in Northwest Europe in the blue, the land is uplifting at rates greater than 3 millimeters per year, offsetting or in actual fact reversing the trend in sea level rise. Conversely, in the regions in red, at the margins of those ice sheets, they are subsiding at rates of up to 2 millimeters per year, amplifying the effect. So if it isn't complex enough, sea level, that you have to understand the process that began 20,000 years ago to accurately project the future, we also need to think about gravity. So static equilibrium is the response of the redistribution of mass from being on our ice sheets into our ocean basins. So these ice sheets, as I've said, are a colossal mass. So water is attracted to them. The ice sheets reduce in mass and the water retreats away from the ice sheets. So again, models that we've produced at the Earth Observatory of Singapore illustrate the effect if Greenland melts or West Antarctic ice sheet melts. So if Greenland contributes 1 meter of sea level, so it melts to rise global average sea level by 1 meter, you'll get a spatial fingerprint where in regions, and this is very counterintuitive, regions around Greenland or along the northern shores of the Arctic Ocean will receive a net sea level fall. The maximum effect is in the southern or tropical oceans. So when Greenland melts and contributes 1 meter, Singapore receives around 1.2 meter of rise. The same for this image of West Antarctica, the area warming faster than anywhere else on our planet. If West Antarctic melts and contributes 1 meter, Singapore receives around 1.2 to 1.3 meters. We then have another human driver, groundwater withdrawal. We can withdraw groundwater, we can extract hydrocarbons. And if we do that, we cause a compaction of the sediments and you cause an amplifying in the effect of sea level rise. On the left-hand side is some imagery that the Earth Observatory of Singapore did using INSAR satellites to measure how the ground surface of Jakarta is changing. And it is this information that the Indonesian government has used to think about moving its capital, because areas in Jakarta are sinking at 10 to 15 centimeters per year. Another process for which at the moment, and this is just to illustrate, we do not know how it's going to impact sea level or future earthquakes, because we know from observations of the past that the earthquakes will influence land level changes both near to an earthquake, but also several hundreds of kilometers away from an earthquake. We know this by looking at the Indian Ocean rupture in 2004 and analysing tide gauges in Thailand. After the 2004 event, we've seen around a 20 centimetre rise in sea level on the west coast of Thailand, much of that driven by land subsidence. So now we're looking at potential areas of future earthquakes, particularly elsewhere along the Sunda megathrust, that if it was to rupture, would cause a similar subsidence here in Singapore. So now let's start to look at some data. First of all, I'm going to look at changes in sea level in the past, then we'll look at the present, and then we'll move on to the future. So if we look at sea level in the past, what we have here is an animation looking down at the North Pole, and it's run at 2,000-year time steps. So we have the large ice sheets in North America and Europe. These ice sheets were colossal. They stored 120 meters of water within them. Therefore, in the tropical regions, such as Singapore, sea level was 120 meters lower at the last glacial maximum 20,000 years ago. And on the right-hand side, you have an animation that shows this. We can see that 20,000 years ago, if you were in Singapore, you could walk to Sumatra, to Malaysia, to Thailand. You could walk to Borneo and through land bridges to the Philippines. But then these ice sheets disintegrated, they broke the land bridges and flooded the continental shelf areas around Singapore. And they created the Southeast Asian genome that we have today. We were once a group of species living on the same landmass. Sea level split our genome, and that's why the Southeast genome is so varied today. So let's just look at this graphically. So these are areas that I've researched in. So in my PhD and postdoc, I worked in Scotland. When I moved to the United States, I worked along the Atlantic seaboard. So in Scotland, coastlines that formed 16,000 years ago, if you want to find evidence for it, you have to go 40 meters up into the mountainous areas to find those former shorelines because the land has uplifted. Conversely, in New York City, it was at the margins of those ice sheets, so the land subsided. So a shoreline formed 10,000 years ago is now 30 meters below your feet. But here in the far field, in the tropical oceans, the glacio-isostatic adjustment is not significant. So you just record what the oceans are doing, rising rapidly in the last, between around 12 and 8,000 years ago, before being stable in the last 6,000 years. And it is this understanding of the past that enables us to explain the sea levels of the present. So we can measure sea levels of the present day either using tide gauges. So at our ports of our world, we measure tides high and the low water for mariners, the average of which is the average sea level of that day. You build them up, you get the average sea level of the year, and you can have a time series. And tide gauge records in the Northern Hemisphere, Northwest Europe, and the United States can stretch back through the 20th century. Occasional records go back earlier. Since 1993, we've had satellite-based missions. They circumnavigate the globe and they measure sea surface heights. This graphic is just data. One of the questions that's asked about climate scientists is sea level accelerating? So what I did here is I showed a variety of different studies that showed what the rate of sea level rise was in the 20th and 21st century, or in the blue, just looking at the record since 1993. And it doesn't matter which data set you look at. When you look at 20th century values, there's somewhere between 1 and 2 millimeters per year. When you get into the latter 20 or 30 or so years, it accelerates through to around 3 to 3.5 millimeters per year. How does the globe compare with the local? So if we look at one of those estimates on the previous one, in the 20th century, we can have a rate from this particular study of around 1.2 millimeters per year. Then when they're matched with the satellites, they increase to 3 millimeters per year. If we look at the other records in Norway that were underneath the Fenno-Scandinavian ice sheet have land uplift. So they're not recording global sea level rise, they record a net sea level fall. In Oslo, they do not have the problem of increased sea level rise. They have the advantage of creating coastal land areas. They have a coastal area that is expanding into our oceans. Conversely, in New York City is subsiding, so they do rates that are far in excess of the global mean. But what about the Philippines? Slow throughout much of the 20th century. Then when they start to deplete the aquifers, an acceleration to rates of 15 millimeters per year. But remember what I said about Jakarta? Jakarta's 15 centimeters per year. Here in Singapore, we have a very small instrumental record, but we sort of match the global record. Okay, next, I want to have a look at the future. So I'm going to look at two different publications that I put together. The two publications, the first one is just looking at the evolution of sea level projections, really trying to put into context where we are as a scientific community. So this graphic shows the database of all of the sea level projections that have been made by the scientific community. So the first sea level projection was made in the 1980s, 1982, by a scientist known as Vivian Gornitz, who works for NASA. And we've got all this data up to 2018. The size of the circles is the number of studies that were done in that particular year and the number of projections that those studies amount to. So Vivian Gornitz only used one projection. She just doubled the amount of carbon dioxide in the atmosphere and looked at the sea level response. Whereas we look at years such as 2017, there were 11 studies that in total looked at over 50 different projection scenarios, from the highest emissions to the Paris Agreement, a 1 degree C, a 2 degree C, a 3 degree C world. This graphic illustrates the individual studies compared to the projections from the IPCC for a high emission scenario. And the point of this graphic is to illustrate that the governmental policies are mainly based around the IPCC. So any governmental agency normally turns to the IPCC, and we can see that they are an underestimate compared to the individual studies. So on here we have the year of the study, we have the sea level rise for year 2100, and we have the projections from the different IPCC, the first, the second, the third, fourth assessment report and the fifth assessment report. And then we have the individual studies, be they using an expert judgment, I'm going to show you an example of that in a minute, or a variety of different processes. The conclusion here is that the IPCC is erring on the least side of drama. It is being conservative compared to the upper projections of those individual studies. So I was concerned about this. So I was concerned that the IPCC were too conservative. So I thought I'd try and survey sea level scientists to see what they did. So this is known as an expert elicitation. It's very, very useful when there are great uncertainties in the science. So it was anonymous. We selected 100 scientists And they were the 100 scientists that had written at least 5 papers on the topic of sea level in the previous 5 years. And we asked those scientists what they thought sea level would be at 2100 and 2300 under a low emission temperature scenario and under a high emission greenhouse gas temperature scenario. Now, I did this survey also in 2014, not to the same people, but to the same group of people, the same search criteria. And therefore, I could look at whether there'd been an evolution within the scientific community. So what we show here on the left-hand side is low emission, on the right-hand side is high emission, on the top row is 2100, and on the bottom row is 2300. So under the low emission and the high emission, there's no difference really between the 2014 and the 2019 study. They're indicating an upper range of sea level at the low emission. This is global mean of somewhere between 82 and 94 centimeters, and under a high emission, somewhere between about 1.5 and 1.6 meters. When we look out to 2300, there has been a change. There's an increased tail at both the low and the high emission with the more recent elicitation, indicating the scientific community is even more worried about the long-term instability of these ice sheets. This graphic just illustrates 2100 and how we compare with the IPCC. Again, furthering our worry that the IPCC is underestimating. So finally, to wrap up, let's have a look at some individual projections using one process-based model which matches our expert elicitation, which we can look at the global mean and then also look at local projections. So I'm going to show you a variety of slides for different locations. First of all, I want to look at the global average. So this is from Robert Kopp. He was one of my colleagues at Rutgers. He has a probabilistic projection that can look at different local regions of the globe. We're going to look out to 2050, and then we're going to move on to 2100. We're going to look at a low emission in blue and a high emission scenario. So if we look at the first glance, if we look out to 2050, the take-home point is that there isn't really a difference based upon emission scenario. It is only when you go out to the latter part of the 21st century when the impacts on our ice sheets are particularly felt and they separate. So here are our global numbers, somewhere in the order of 1.5 to 50 centimeters by 2100. Let's compare this with Oslo. Okay, so Oslo, the land is uplifting. So in Oslo, moving out to 2050, high or low emissions, no negligible sea level change. We do have some when you include the uncertainties when we look at the 95th percentile. And indeed, when we go out to 2100, the 50th percentile indicates no net sea level change. However, under a high emission, you get up to nearly 1 meter, 50th percentile. And for a coastal scientist such as myself, I don't know what that means for regions around Norway, because for 20,000 years, that coastline has been experiencing sea level fall. And somewhere in the next few decades, under a high emission, it flips signs. And I don't know what impact that'll have on ecosystems, coastal geomorphology, or the infrastructure. And nobody does, because nobody's observed this. Let's move to New York City. So New York City is sinking because of that extinct ice sheet, a non-climatic forcing. And we can see that it's greater at 2050. But now when we're getting through to 2100, we're getting values of around 1.7 meters. Singapore, well, Singapore is indicated by the tide gauges. The Static equilibrium is balanced out by negative influences from other processes, meaning that Singapore seems to match the global mean virtually identically. It has, I mean, I think when we think about Singapore, when you're looking out to the end of this century, the difference between 51 and 1.5 meters is staggering. It's staggering in magnitude, but it's staggering in rates of change. If you go to Marina Bay Sands right now, the ocean water levels there are rising at about 4 millimeters per year. At a low emission future, the average would be around 6 millimeters per year by 2100. And I would safely say that our ecosystems are able to survive, and you can have engineering solutions. 1.5 meters means at some point at the latter part of this century, sea levels will be going up at around 20 to 30 millimeters per year. That rate of rise has not been seen since 14,000 years ago, when those northern hemisphere ice sheets collapsed and broke all those land bridges in Southeast Asia. 30 millimeters per year. Corals can't survive that, they go extinct. Mangroves can't survive that, they go extinct. And there is not an engineering solution applicable. That's sea level rise. You keep to the Paris Agreement, we survive. You don't, it's an existential crisis to civilization. And then finally, if you look at the Philippines, because of groundwater withdrawal, it's just off the park. 50 centimeters by 2050, a median of 2.1 meters by 2100, a 95th percentile, a 1 in 20 chance of 3.2 meters. I'm sorry, that the Philippines can't survive those rates of rise. Even now, it is in terrible, terrible trouble. So to conclude, I'm just going to tell you just a little bit about what we're going to do. So we've got this funding, and our aim is to try and understand these processes. I've illustrated there's one process we don't know how to incorporate, tectonics. We also don't really have an understanding of ocean dynamics in and around the Singaporean waters. And until we understand those processes, we're not able to fully project with the full range of uncertainties. Our aim in the next few years is then to use those uncertainties to look at some projections and look at adaptations and look at education and communication. And the Earth Observatory and our sea level program, our ultimate aim is to try and grow homegrown resources on this, because sea level rise and other climate problems are things that we're going to have to understand now and for the next few decades. So thank you for listening to me. I'm sorry I went 10 minutes beyond time, but I wanted to make sure I got all that information in. And while I've been talking, it's got exceedingly dark in my office. There's a massive storm that's coming. So I'm just going to go and switch the lights on. Thank you very much.
Thank you, Ben. Actually, in terms of timing, it's perfect. So we still have 40 minutes for Q&A. So the presentation was really great. I don't know how the audience feels, but I feel that the presentation, or you have actually pumped my knowledge about sea level from very low level to, I won't say very high, but maybe a very decent level now. So at this point, I guess you guys and I hope to use our privilege to, as moderators, to ask a few questions first. And then we will challenge Professor Horton with the questions from the audience.
That sounds fine, Simba. I'm willing to take any questions, and any questions we don't have time for, it can always be emailed to me, and I can respond to those, because it's very, very important that we do a Q&A so we can respond to what the viewers want to see. And I think, you know, with sea level rise, the point of this presentation was to show how complex it is, but how much it varies around the globe. So if you're going to look for adaptations, or you're going to look for business solutions, You have to start with the science first, and be that on sea level rise or precipitation, which you can see outside my door, drought, wildfires. You need to know the local science. And what happens today does not necessarily mean that the same level of intensity is faced into the future. You have to have a context of the present and the past.
Yeah, so feel free to ask questions. And then in the end, if we have unaddressed questions, we can categorize them, and then we'll pressure Professor Horton to answer the questions. So I guess the question from me and you, Gash, will be quite related to the point you made in the conclusion slide. So you mentioned that you hope to have risk-based methodologies for education and communication, and you want to have a homegrown cross-institutional scientific community. So our question will be actually about these issues, especially about implications for business, for industry, and for education. So you guys, you want to exercise your right first? Yeah.
Thank you very much. Excellent presentation, Ben. There are a few questions coming in which you might look at, and feel free to take any of those. But I guess I'll start with the kind of bigger, as simple as the what to do and what should we do kind of thing. And we sit in education, so I guess I could start with the question about what we can do in terms of the education sector to help avoid these kind of worst case scenarios.
Well, I obviously have spent my career in an education sector, and I've seen the power of knowledge. And that's the key about climate change. It is very, very hard to force a community, well, from an individual to a community, to respond to climate change without education. If people are presented with the facts and the knowledge, the implications, then you would assume that people would act accordingly. So, you know, in my career, I formerly worked at the University of Pennsylvania. So that has the Wharton Business School. So I was very aware that many of what you would say, the movers and shakers in US or global business do some form of their education in the Wharton Business School. So I made it my mission to educate people in the Wharton Business School about climate. So I remember going to see some of the directors of the Wharton Business School, and I said, look, can we get everyone who's involved in risk analytics to actually take a course in my school, which was an earth science school, on climate change? And then that became part of the Wharton Business School's curriculum. And I think that that's the importance. If you have a knowledge of how the earth works, then whatever field you go into, you're going to start to value the earth. This is the problem with climate change, is that we don't put a true price on carbon. So if you think about, for example, Singapore has a carbon tax of $5 per gigaton. That is so insufficient. If we truly look at the impacts of carbon on the atmosphere, and then their impacts on sea level rise, impacts on wildfire, the carbon tax should be somewhere in the order of around $100, perhaps even more. And if you value the earth, then things, quite simply, as the pandemic wouldn't happen. If we truly valued biodiversity, and we didn't shove species and species together, and then humans and species together, we would not have had the pandemic. I truly believe it's education. And here at NTU, well, NTU had a great vision. They started the Asian School of the Environment in collaboration with the Earth Observatory of Singapore. So here in Singapore, for the first time, we are producing undergraduates who are trained in sustainability. And these are smart kids, but now we need to branch out from the environmental sciences and interact with business. So you guys know the true threats that we face, and we can try and think about market solutions. But personally, the market has to change. The market has to, when you think about stakeholders, some of those stakeholders are planet Earth. not just us. You know, we have to redefine sustainability and really what it means about not exploiting our natural resources. I mean, you know, the facts about climate change. Well, so climate change, I mean, the biggest impact on climate change is going to be on health. Okay, so mortality is going to skyrocket with heat waves. We're going to get transmission of diseases into regions that have never had it before, so they're not resilient. Okay, but the second biggest impact is sea level rise. Far greater than the impacts on the energy sector, far greater than the impacts on the agricultural sector. I mean, the influences on GDP of sea level rise, you know, there's estimates of somewhere between around 1 and 10%. A paper that came out earlier this month said a 4% impact on GDP by the end of this century. And isn't the pandemic a 4% decrease on GDP? That's what you're talking about. And that's because we live along a coastline. 5 of our 10 largest cities are along our coastline. All of our infrastructure is along the coastline. And we don't even factor in our ecosystems because we don't value them at all. Yeah.
Well, in economic terms, as far as I know, according to a recent research, the prediction is, you know, for example, the U.S. economy, the GDP, 10% of the GDP will be knocked off if this situation, sea level rise, actually continues. But in terms of
you're right. China's the biggest affected, though, isn't it? So China has more resources along the coast, about 12% of GDP. This paper that I read earlier this month.
Yeah, but in terms of education, actually, I'm pretty glad to see young generations actually are really active and putting this up on their agenda. You know, this young activists.
Of course. Young generations are very interested, and one of the things that the knock-on effect. So Greta Thunberg has had a huge influence on climate change because it's got the kids involved, and the kids are obviously very bothered about their future. But who do they turn to ask? They ask their parents or guardians. And as a parent, Simba, you don't like to look stupid in front of your boys.
Yes.
You know, if they ask you about climate, hey, Dad, climate change, is it serious? You don't want to sit there and go, oh, I don't know that. You need to have the facts now. Yeah. So it's a knock-on effect. I mean, I think education is important. And what I would like to see at NTU is that I would like to see that every undergraduate has to take a course in sustainability.
Yeah.
I would like to see every student in Singapore take a course on sustainability. So they're armed with the knowledge to make the decisions. And then continuing education. You know, we could make Singapore, the business sector, knowledgeable about climate by running professional courses that try to bring together NBS and the Earth Observatory regarding climate risks.
Yeah, I agree. I mean, at the business school, we feel the huge demand for, you know, climate change or sustainability courses, and we are offering at different level. But we do need, I guess, a more scientific perspective in these courses. So that's why I believe that maybe the collaboration between the business school and new institution will be great in the future. Yeah. Then, do you have anything to add, Yogesh, about the education issues?
Oh, no, I think that was an excellent answer and very much kind of hopefully what we're trying to do here and the direction we're going. So I think that was excellent. I mean, there are some questions coming in on the chat.
I'll just chime in with a quick point before Yogesh in some of the questions from the audience. So Ben and everyone else on the audience, NTU is making a sustainability course compulsory for every undergraduate for the incoming cohort in 2021. And the good news that it is interdisciplinary. There'll be folks from Ben's group and the Asian School Environment, folks from the business school who are currently, as we speak, co-designing the course, and we'll be delivering it together. Yeah, we're moving.
Good, thanks. But I have to ask something first about research because it's my role in the school. So I really want to know, like from your perspective, then that what kind of research in business that you hope to see about sea level rise or climate risk in general, and is there any other actually potential areas for collaboration between business researchers and environmental scientists? What actually both sides can really bring onto the table?
Well, I think primarily it's to bring, greater collaboration among stakeholders from business, governments, civil society, and then science. It all begins with science. So if I think about a specific example is, when I came here to Singapore, so I came here 3 years or so, and I started talking to the agencies such as PUB or SLA, now called MSC, the Ministry of Sustainability Environment, previously MURI, and they sort of like had it in their head that they knew what sea level rise was. And I go, oh, okay, how do you know that? And they'd say to me, well, it's 1 meter. We're going to get 1 meter by 2100. And I went, okay, where did you get that from? Oh, so we've outsourced to the UK government to provide these projections. And I went, oh, okay, that sounds good. And then you delve into the detail, and the 1 meter is the global average of sea level, global average, so not regional changes, of the upper estimate from the IPCC, so an underestimate, but the upper estimate is only the 83rd percentile. So they're only really looking at the 83rd percentile of an upper estimate of a global average. So we know there are a lot of, and it's already, and that report was made in 2014. And so I tried to talk to them that we need to develop here in Singapore our own research centre that can continually produce educated undergraduates and graduates on sea level and other climate risks that then can be placed within these agencies, within business, within government. And it worked. We created the National Sea Level Programme, and where the government put in $10 million to catalyse the science of sea level. So it starts off with sea level. I mean, I think that companies, well, they need to worry about initially, they need to worry about the initial immediate impacts of climate change on their operations. So there are going to be a variety of operations that are very, very susceptible to climate change, depending upon their location and what the climate variables are that will impact them. So anything around a port, you would go, oh, well, that's sea level rise. In certain regions, it's sea level rise plus storms. In certain regions, it's sea level rise plus tsunamis. Other regions have problems to do with landslides and rainfall or droughts and wildfires. You have to understand your climate risk. Then I would have thought that companies need to be aware that there'll be ever increasing regulation on carbon. I mean, we've started off at a $5 tax in Singapore. That is only going to go up. I mean, you can't come in and say it's a $100 tax. You start off at 5 and then it will start to go up. I mean, 5 is low. So the carbon tax averaged around the world is around $30 US dollars. What's that? 35 or $40 Singapore. So Singapore wants to match the world, it will go up. But then I think the whole world will go up further. So there's going to be regulation. Companies are going to have to look at litigation regarding climate change. So they're going to have people within their team who are aware of environmental law, And fourth, related to your last point, there are obviously going to be opportunities regarding climate change and opportunities that their competitors may take first. So I think companies need to be aware of what their current climate risks are. They need to look at what their regulations will be, look at litigations, but also be aware of the opportunities. I mean, I don't particularly like talking about opportunities with climate change because I don't like thinking that people want to try and make money out of the misery that will affect the rest of the world. So they think, well, if climate change gets worse and worse, I will get greater opportunities. We can see this happening with the Arctic Circle and the loss of sea ice, meaning that people are investing in the Arctic. Why are we investing in the Arctic? Why are we even considering drawing petroleum out of the Arctic when petroleum is the problem? And there's, you know, those sort of things always sort of rub me up the wrong way, because we don't want to be making money out of the misery of others. That's happened too much with the free market economy. We need to truly value Mother Nature. And so opportunities, well, I mean, hey, the construction sector, to do with sea level rise, the construction sector. So construction sectors that look at defending the coastlines, but ones that defend the coastlines using value added, so they have natural solutions, they create biodiversity as well as protecting the land. They're the sort of aspects. And obviously anything that involves green technologies. We've seen a variety, or I've seen a variety of presentations about offshore solar, offshore wind farms, all trying to move into the renewable energy sector. So, you know, companies who have assets in petroleum, they're going to be stranded. There's no doubt about that. Currently on the globe, we have enough oil assets to take us well over the Paris Agreement. We can't use them. I don't know why we're going exploring new ones. But so companies who have their assets, you have your shares, you know, your personal pension in petroleum industries, they're going to be stranded. You know, you've seen this movement away from petroleum assets. I think that will only continue.
Yeah, I guess the business sector has come a long way. This is my personal opinion in addressing the challenges. And then, but I also believe that, you know, every cloud has a silver lining. This actually in the process of you know, mitigating or adapting to this sea level rise or climate change. We do really have some good business opportunities, as you mentioned. For example, you know, we have to have some investment made, and some money will flow to, for example, renewable energy sectors, and those many companies will benefit from these efforts. So, yeah, that's I guess something we can focus on for business research. And right now, in the past 2 years, especially, we really have a burst of studies on climate risk and business implications. We call this area climate finance or green finance. So it's really happening and getting really, really exciting. A lot of papers are coming.
We've got some advantages here at NTU. You've got the science here at the Earth Observatory. You've got risk being analysed by the Institute of Catastrophic Risk Management, ICRIM, and then we've got the business school. And so we can start to put this together in terms of what's the science, what's the risk, what are the solutions that's best for business. I mean, you know, hey, you know, you and I, Simba, we sit down and have a beer after football, well, prior to the pandemic, but we really should try and sit down as a group and try and think about how to get something collaborative within the university to address these problems and help the city of Singapore, but more importantly from the Earth Observatory to help our neighbouring countries regarding this. Yeah,
let's do that. But we'll have to give time to our audience. We have actually a lot of questions. You guys, where you want to start?
Well, yeah, we have a huge number of questions coming in. It's going to be very difficult, I think, Ben, to address them all. Some of them may be, you may need to kind of do bilaterally, as you kindly offered earlier. But there are, let me try and clump a few together, which is, you've touched on a little, kind of one group of questions about what can we do as governments, corporations, individuals. We've talked a bit about that, but if you want to come back with, you know, kind of a few key takeaways on that. Another question is on international collaboration. So how does the science feed back into the international kind of governance community, and what more can they do, and what are they doing, I guess? So I'll give you that collection of questions, and I might as well throw in kind of another set of questions, which are about the clear trend of digitization and the requirements, for example, of moving to electric cars and e-everything, and the implications for demand for electricity and whether that can be sustainably produced. So let me throw those at you, and I have some more after.
Okay. All right, I'll try and remember them. But okay, so I'm just going to repeat myself. It's all about education. So, I mean, you know, to get a change on climate change with the public is going to require education. So everyone is aware of the problems, and everyone is aware that in many cases, the solutions that are offered to reduce our amount of greenhouse gases, sometimes they're just band-aids on the problem. You've got to look at the root cause. You know, so if I just look, you know, to answer your question, maybe I could just focus in on one of the questions on the board. So the first question that was asked was, how does ice form in Greenland and Antarctica? Can it be reversed? Okay, so this is all about education, and it relates to a message. So we're in the middle of a pandemic, okay, but we're all very, very hopeful of next summer that we'll have a vaccine and we'll be able to go back to our lives. With climate change, there is no vaccine. There's no vaccine, and I'll answer that by ice sheets. We can melt and disintegrate Greenland and Antarctica if we don't do anything about Greenland. If we don't meet the Paris Agreement, we'll take our temperatures above 2 degrees C and the ice sheets will shatter. We can do that in a decade. Set the wheels in motion that those ice sheets disintegrate. Do you know how long it takes to regrow an ice sheet? 100,000 years. That's why there's no vaccine. You can't refreeze an ice sheet. You can't say, oh, can we take out the CO2 now? I'm really worried about this. No, because CO2 stays in our atmosphere for hundreds of years. And the melting of our ice sheet that we see today is a result of the CO2 increases since the Industrial Revolution. We've set those wheels in motion. Sea level will always rise. What we want to do is stop it being catastrophic. The Paris Agreement is key. Paris Agreement was made in 2015 based upon scientific information, and the idea was that we needed to keep global mean temperatures below 2 degrees C above pre-industrial. We're already at 1 degree C, so we've got a 1 degree C wiggle room. Indeed, the scientific community wants to decrease it even further. But if we think 2 degrees C, because above 2 degrees C, the ice sheets disintegrate. How do we know this? Well, one of the key aspects is, and this is what I like about it, it's going back into the past. And so if you go back into the past, 120,000 years ago, because the Earth's orbit around the sun was slightly different, we were 1 to 2 degrees C warmer than today. It destabilized Greenland and Antarctica, and our sea levels were 4 to 7 meters higher. Let's look at the end of this century. If we do nothing about climate change, we go on business as usual, temperatures will be 4 to 5 degrees C warmer than today. When in the Earth's history was it last that warm? The Pliocene, 3.3 million years ago. In the Pliocene, the Earth's orbit around the sun is similar to today. In the Pliocene, they had carbon dioxide values of around 430 parts per million by volume. We're at 415. We will reach 430 in the next few decades. What were sea levels like in the Pliocene? 10 to 20 meters higher than today. So we know what happens. We have the Paris Agreement and we keep to it. I'm more hopeful now about keeping to the Paris Agreement than I was at the beginning of November. And that's quite simply because Biden has been elected president of the United States. So Biden signed up to the Green New Deal. I mean, when President Obama was in power, he stated that we would meet the Paris Agreement, that there would be a 25 to 30% reduction in greenhouse gas values comparing 2005 to 2030. Trump comes in, out of the Paris Agreement, removes all these regulations. Biden's in, he's re-signed up to, he said the first thing he will do is re-sign to the Paris Agreement, and he's made a pledge to cut greenhouse gas emissions by 2030, carbon neutral by 2050. China have said carbon neutral by 2060. We now have 30 or more countries, some of the largest emitters, have said carbon neutral by 2050. It's driven by science, but the public has to buy into this. And again, the only way they buy into it is education. How is it going to affect you? I mean, I'm a parent. I do not want to bring up my children in a world where their future prosperity is the result of the lack of actions of our generation on climate. Because when I was born into the world, my mum and dad didn't think that my success would be driven by the amount of carbon dioxide in the atmosphere. Our children will be. Got to change. Got to change.
Okay, thanks for the answer. Actually, you have answered one of the questions accidentally. Is one of the attendees actually asked whether the actually the process can be reversed, so whether we can have more ice. I guess your answer is it's almost impossible.
No, but we can use the Earth. I mean, so when we think about solutions to climate change, I'm very much in favour of natural solutions to climate change. So, the Earth has a carbon cycle. So carbon dioxide's always been in our atmosphere. If we didn't have carbon in the atmosphere, we wouldn't have the blanket that keeps us warm. We wouldn't have any life on Earth without carbon dioxide in the atmosphere. So it's a very important gas, but the Earth has been recirculating carbon. So one of the things that I'm very much in favor is any natural solutions. So we can think about ecosystems. So about a quarter of the change in radiative balance of the Earth in the 20th century is a result of deforestation. Our plants, they take in carbon dioxide through the process of photosynthesis, producing the oxygen that we breathe, but taking in the carbon, storing it in their leaves, but most importantly, storing it in the roots and the soils and burying that carbon for hundreds to thousands of years. So we need to stop deforesting for a variety of reasons: biodiversity, social problems, but also to do with the carbon storage. Now, the most efficient natural ecosystem are, in fact, mangroves. So mangroves that are on the coastlines of the tropics are 5 times more efficient than any other ecosystem. And so they store huge amounts of carbon, but unfortunately, many regions, they are removing. In Singapore, we've lost nearly 90% of our mangroves in the last 50 years. Because people don't, goes back to one of my earlier points, they don't value the environment. They just think mangroves, we can get rid of them, so of no value. But mangroves are important for buffering the coastlines from erosion. They filter our drinking water. They're incredible breeding grounds for fish that end up on our coral reefs and end up in the food web, but they store carbon. But very, very few people care about that. They just want them removed for coastal development. And this is all about why the free market does not work, because it doesn't value the natural ecosystem. If people who own the land realized how important they were, maybe they'd want to regenerate the land. All our regeneration at the moment of natural ecosystems is through philanthropic activity or governmental ventures. There's very few commercial activity because we don't place a value on that land. If we truly priced carbon, then the mangrove areas will be worth significant amount of money. So people would want to maintain them. They maybe outcompete other resources for that coastal land. Yeah,
it would be great to have some commercial rewards for doing this.
Yeah, but we're going towards that way. NCARTs have a program. It's with NTU and NUS to look at the natural ecosystems in and around Singapore. It's led by Dan Fries at NUS, Natasha Bhatia at ASE. It's going around trying to fully value those ecosystems.
Mm. Okay, the next question actually is about how different countries deal with this issue. A question from my colleague Wish actually is about Singapore. So, for example, according to your prediction, if we maintain the current emission, then Singapore cannot really handle the situation maybe 50 or 60 years later. But how can Singapore adapt, or what Singapore can do? Because no matter what we do, if people in other countries, they still increase their emission in the end, we still have the trouble we cannot deal with. And then we have people worry about the situation in Indonesia, Philippines, and Vietnam as well, because our audience from different countries. So do you have any suggestions about these issues, and maybe any suggestions for a particular country you think is worth discussing?
Well, okay, so regarding the problem with sea level rise, it's again mitigation and adaptation. So you can't solve the problem by adaptation alone. We cannot adapt to rising sea levels without reducing the rate. So we must, repeating myself, but we must meet the Paris Agreement. In my idea, the only way we're going to meet it is by educating as many people as possible about the problems of climate change. But adaptations regarding sea level rise, well, they're threefold. You either stop the water coming in, so you build seawalls. Hopefully you would do something more innovative that involves some natural benefits in terms of biodiversity. So you stop the water coming in, or you live with the water. So you allow the water within and you raise the land area. So Changi Airport Terminal 5, if it ever is to be built, the runway for there has been elevated to 5.5 meters above sea level. So that elevation incorporates around a 1.5 meter rise in sea level. So if we look at that, doesn't account for a 1 in 20 chance under a high emission, but under a low emission future, it does reduce significantly the amount of sea level rise. So if you do either of those two aspects, you either stop the water coming in or you learn to live within it, the impact on GDP is going to be far, far less. It's estimated that fully incorporating adaptations reduces the impact on GDP by about a factor of 10. The third solution, which is of no use here in Singapore or other small island nations, is that you relocate. So you basically retreat away from the coastline. And we've seen that in certain regions. I've been involved in studies that have looked at the retreat of coastal populations, both on the Atlantic and the Gulf Coast of the United States. Here in Singapore, it's a non-starter. We have approximately, and this was illustrated by the Prime Minister, we have about a third of our land mass in low elevation coastal zones that are subject to flooding. We've got nowhere to put those people. And that's why sea level rise is an existential threat to this country. But Singapore has invested in the science. But Singapore has the dollars to invest in protecting its coastlines. Our developing nations may not be as fortunate. They don't have the scientific information yet. So the aim of the Earth Observatory is to really use the skills and the experience that they've had in tectonics and volcanoes to take our information here at the Earth Observatory and transmit it out to our agencies abroad. So they have all of this information freely available. And then they can start to do their own practices on what adaptation is possible and what the risks are. So that's what we're trying to do. That was a big part of this Tier 3 Southeast Asian program, was to use the experiences of the Earth Observatory in partnering with our neighboring countries. Because, as I illustrated, there are certain countries that have significant problems. Manila in the Philippines, Jakarta in Indonesia, but we need to provide that information so they know what's ahead of them.
Yeah.
Oh, look, I think we're almost out of time. We've got 6 minutes. So you've answered a lot of the questions in the course of this discussion, if not, specific questions. I think you've touched on a lot of the key points. You'd mentioned one thing earlier, which was the analogy to COVID, but from the point of view that we don't have a vaccine for climate change, which is a really nice start way to put it. But trying to kind of end on some positives, COVID, as tough as it was a kind of a raising of the consciousness of these left field events, these once in a very long period kind of shocks. Could this in itself help elevate the concerns of and policy responses to climate change?
Well, before I answer that, I'll just come to your other point. I mean, anybody who's met me doesn't find me to be a depressive person, sits there moaning and complaining about life. I mean, I've been studying climate change and sea level rise for 25 years, and I've always been very, very hopeful that people will make the right decisions if informed about the problem. Being in education, I mean, we have the pleasure to educate these young, bright, smart minds. And when I talk within ASE, when you're talking to these students, you know that they will find the solutions to climate change. We as a generation just have to give them the time. We have to act now so they then find the solutions to maintain this planet. So I'm always hopeful. The COVID pandemic, well, I mean, an unbelievable tragedy to the planet, the lives lost, the lives affected. We'll go on for generations, this impact of this year, but perhaps a legacy for peoples whose lives has been affected is how we regenerate from the COVID pandemic. We saw that during the COVID pandemic that air quality improved. We saw biodiversity flourish. I mean, we know about air quality. Some sensors looking at, for example, areas over Beijing in China showed that the air quality was some 40% better than it was the year before. About CO2 emissions reduced, but that was all forced upon us. It was forced upon us because economies were shut down. We didn't travel, both air or commute. Well, what we need to do now is just think about whether what we truly value. I know what I value. I value my friends. I value my family. I don't value materialistic objects as much. I mean, so it's what values that COVID has instilled in us. And then we also have, and it's horrible to say this, but it is a unique opportunity to kickstart our economy, because we have to do this. But how do we invest in that? Do we go back to our old means and invest back into, let's say, petroleum, or do we invest in green technologies? And we can see that there are a variety of enterprises. European Union, on climate change, we commonly look to the European Union. I mean, being British, for some unknown reason, we decided to remove ourselves from the European Union. I haven't got a clue why, because what the European Union fundamentally stands for is for peace and prosperity and helping those less fortunate than yourself. And that's what I stand for as a British person. But the European Union, its regeneration is very, very heavily linked to the green technology. And it's something like 40, nearly 50% of the funds have to be in green tech. And that's the role model for all countries. Do that, we invest in those jobs. There's no reason why renewable energy cannot be as cheap for Singapore as liquid natural gas. No reason with technological developments. Just think about, I mean, if you really just take a step back, to get liquid natural gas, geological explorations, taking it out of the ground, volatile liquid, transporting it in, not thinking about the impacts on the environment and how much do we pay at the pump. Solar energy, it's always going to be there. Yes, we have cloud cover, but it's always going to be there. We can supply energy for the whole of the planet at minimal cost. Why not? Why not? We talk about COVID pandemic and this amazing, about the COVID pandemic. Who's going to solve the COVID pandemic? It's not a politician. It's not a social media star.
Mhm.
It's a scientist,
Mm.
a junior scientist working in a lab, hour upon hour, will save this planet. Same on climate change.
It's the power of science. Okay, so I guess we'll have time just for one quick question from the audience. So will EOS be interested in collaborating with industry players to look at coastal protection initiatives and measures? So this is
Well,
maybe
I can answer that in 1 second. Yes. But I could just say just a little bit is that, you know, the Earth Observatory started out from nothing. There were no earth science students, professors in Singapore. And so it started out building up a level of knowledge. It had no links with international agencies, started out building out agencies. We didn't have an undergraduate program. We started out building an undergraduate program. The Earth Observatory of Singapore has done phenomenal things for knowledge base, collaboration, and education. I mean, if you really step back, you go, wow, all in 11 years. Now we've got to think about where do we go from here? And now I think we have, you know, the junior professors here have become more senior, so they're more established. We have the Asian School of the Environment. Our agency network is based upon trust. Now we can venture out and work with industry. I think that's the next step. We've begun the education, the agent. The next step is through business.
Yeah. So I will encourage the audience to contact Professor Horton directly if you have any ideas of collaboration. So this webinar has to come to an end. We still have a good number of unanswered questions. I noticed actually there's a question for me as well about the finance issues. I will categorize the questions and try our best to address them. I will communicate with all the audience with email as soon as we can. So I guess to summarize, we have learned a lot about the causes and consequences of sea level rise. So the situation is really urgent. Just according to Greta Thunberg, our house is on fire, so have to do something. So I guess everyone has a part to play to combat the climate change and its impact because it's just the right thing to do. So I have to say, as a business researcher, we actually, all the business researchers perhaps, maybe a little bit late to the game. But we have realized that there are actually many important research questions. So given the training we had, we are trained to assess risk and manage risk, to hedge the risk. This is actually part of our job. But given our toolkit and interest for research, I guess I'm confident the engagement of the business research community will lead to valuable contributions and help society to address this huge issue in the future years. So you guys, do you have anything to add to end the session?
I think given we're out of time, I just think that's great summary, and I'll kind of summarize a couple of more points by Prof. Horton, which I think we all need to keep in mind, that we have perhaps lots of reasons to be optimistic, including the potentially unique configuration of global leaders been mentioned. We have now the president-elect Biden, who's certainly kind of right-minded about addressing climate change. You mentioned the European Union, who I'm also a great fan of, and I lament as a Brit us leaving the European Union. The European Union's commitment to carbon neutrality by 2050, you mentioned. I should also throw in the 750 billion euro recovery package, which has been called by Ursula von der Leyen, the president of the EC, as the European Green Deal, which is really encouraging. China's commitment to carbon neutrality. But we haven't really focused much on business and investment, but they're also on board, right? I mean, there's a very, very famous letter by Larry Fink of BlackRock last year, which was really kind of shook the industry. We need to do something about this as custodians of the assets, not as owners. And even companies like BP, again, committing to carbon neutrality by 2050. You can get a little cynical about companies with a 30-year view, but nevertheless, I think we've also made real progress on education. I think everyone understands, the need. And in fact, the business and finance reaction to moving in the direction of sustainability is, I think, because the asset owners, us, the people, are really pushing this. And similarly, I think the political reaction is a function of us, the people, pushing this, the rise of the green movement. So upon those optimistic thoughts by Professor Horton, I think we'll wrap it up.
Okay. So finally, I want to thank our communication team, Sean, Cynthia, Ashak, Florence, and Yaling for working behind the scenes to make this so smooth and successful. So in the end, I guess I also want to thank the audience for participation and great questions, and we will address them via email for the unanswered ones. And now finally, the last thing I want to do is, today we have like 3 people running the show. It's just a coincidence that all of us actually fancy the same football club. We're back to football, so which is Manchester United. So I know especially Ben is actually a die-hard fan for Manchester United. He grew up watching the team play since he was a little boy. So as a token of appreciation for his time and dedication, so we prepared this gift. So this is a jersey. I think this is the jersey for Manchester United, but you can see the color is actually for away games, not for home games, because you are presenting at the Nanyang Business School rather than college. Okay. So thank you again for your time and dedication to the research community and to you. And then I hope all the audience can join us in future sessions of this distinguished speaker series. We will talk about different topics such as infectious diseases, AI, machine learning, and other issues. Yeah. Christina, you have anything to add in the end?
Thank you, everyone. Have a very good weekend ahead. Thank you, Ben, especially.
Thank you. Thank you.
Thanks.
Okay. Thank you. Thank you. See you
Bye-bye.
next time. Yeah. Bye-bye.